going to review factoring and solving polynomial functions. So your essential question is, what are some things to check for when factoring completely? So this will be a review lesson for most of you because we've already done factoring first semester. So just to review, there are different types of polynomials that we can factor. One type is a general trinomial. This one has a coefficient that is not 1, so whenever there's a number in front of the x squared besides a 1, the only way to factor is to use the AC method. And when we factor it, we get the answers of 2x plus 5 and x minus 4 as the factors. Another type that we had was a perfect square trinomial. And you can use the AC method or just finding factors of 16 that add to be 8. You can use that method to factor it, and we get that x plus 4 times x plus 4 is what equals x squared plus 8x plus 16. Another type that we had was called a difference of squares, and this is when both of the numbers are perfect squares, so I can take the square root of 9x squared and I can take the square root of 1, and if I do that I get 3x and 1. So my factors are going to be 3x plus 1 and 3x minus 1, because the middle part has to cancel out. That's why I have one factor that's plus and one factor that's minus. And we just factor by taking the square roots of those numbers. And then the other type that we did was just taking out the greatest common factor or finding a common monomial factor. So for this example, the only way to factor this would be to take out the greatest common factor. So I could take out a 4 from both numbers, and I could also take out an x. So the greatest common factor would be 4x, and then I would write what is left inside the parentheses. So this would be the factored version of 8x squared plus 20x. So those are just reviewing the types that we've done. So now we're just going to do some examples. So factoring completely, when the directions say that they want you to factor something completely, that is when an expression is written as a product of unfactorable polynomials that cannot be simplified any further. So basically, you want to factor until you can't factor anything that's left, and then it's factored completely. So let's go ahead and try a few examples. So for example, if I looked at this, if I had 2 times x plus 1 times x minus 4, I can't simplify any of those factors anymore, so that's factored completely. And also 5x squared times x squared minus 3, I can't factor down any of those any further, so both of those are factored completely. Now this would be an example of what is not factored completely. If I have 3x times x squared minus 4, that is not factored completely because x squared minus 4 is a difference of squares. So I can factor that down into x plus 2 and x minus 2. So because I can simplify that more, that would be an example of one that is not factored completely. So in case you were wondering, those are some examples. So here, we're going to factor the polynomial completely. Now anytime we're factoring, we always have to check for one thing first on every single problem, and that is to factor out the greatest common factor. So you might want to make a note of that. Always check to see if you can take out the GCF first. So that's the number one thing you need to check for when we're factoring completely. So if we do that here, what would be the greatest common factor of all of these terms? What could I take out from all three things? Well, I notice that they all have an x, and I can take away at least one x from each term. So if I take out an x, then x cubed divided by x would be x squared, because I would have to make 3 of them, plus 2x squared divided by x. If I take an x out, then I would have 2x left. And then negative 15x divided by x would just be negative 15. So this is what's left. So is this factored completely? Well, no, because I can check to see if I can factor x squared plus 2x minus 15. So to factor this one, because it's a trinomial, I'm going to try to find factors of negative 15 that add to be 2. So you can use the AC method, or you can just find factors of negative 15 that add to be 2. So factors of negative 15 that add to equal 2. So I could do 1 and 15. That wouldn't work. I could do 3 and 5. So if I did 3 and 5, which one would have to be negative so that it equals 2? The 3. So therefore, my factors are x minus 3 and x plus 5 for this portion. Now remember, we had this x in the very beginning, so we need to leave that in the front. Because otherwise, if I multiply this back out, I won't get what I started with if I leave that x out of the front. So always make sure you bring those things down when you're working these out. Okay? All right, let's try another example. So here we have 2y to the 5th minus 18y cubed. So first, remember, we always have to check for what? The greatest common factor. So what would be the greatest common factor of these two terms? Well, I can see that I can divide both numbers by 2, and then they both have y's, so I need to figure out what's the greatest number of y's that I could take out. Well, I could take out y to the 3rd from this one, and I can take out at least y to the 3rd from that one. So 2y cubed is my greatest common factor. And then if I divide and write what's left, I would have y squared, because I have to make 5 y's altogether, minus 18 divided by 2 would be 9. And then I took out the y cubed, so that would be it. Now I have to check to make sure that this is factored completely. I can't break down the 2y cubed. Can I break down y squared minus 9? And I can, because if you notice, y squared minus 9 is called a difference of squares. Y squared is a perfect square, and 9 is a perfect square. So if I take the square root of y squared, what do I get? Y. And if I take the square root of 9, I get 3. So this part breaks down into y plus 3 and y minus 3. Because I'm basically finding factors of negative 9 that add to be 0 because there's nothing in the middle. So that would be 3 and negative 3. And then I need to bring down the 2y cubed. So this would be the version that was factored completely. Okay, let's try another example. 4z to the 4th minus 16z cubed plus 16z squared. So, first I have to check for what? The greatest common factor. So, what can I divide all of these numbers by? 4. And they all have z's, so what's the largest number of z's that I can take out from each one? Z squared. And then I write what's left inside the parentheses after I divide. So 4z to the 4th divided by 4z squared would just be z squared. Negative 16z cubed divided by 4z squared. 16 divided by 4 would be minus 4. And z cubed divided by z squared would just leave me 1z. And then 16 divided by 4 again would be 4. And the z squared goes away, so this is what's left. And then I just check to see if this is factored completely. So I can't factor this down. Can I factor this trinomial? Well, are there any factors of 4 that add to be negative 4? So factors of 4 that add to be negative 4. Well, I can't do 1 and 4. I can do 2 and 2, but both of the 2's would have to be negative to make negative 4. And if I take negative 2 times negative 2, I get positive 4, so that's okay. So then I would get 4z squared times z minus 2 times z minus 2. And so that would be the version that was factored completely. Okay. Now this is something new that we haven't learned how to factor yet. This is called a sum of cubes. So what this means is, and this is a formula right here, so I don't want you to be confused by this. If I have an example like a cubed plus b cubed, and I want you to factor this, this is the formula that you would use to factor a cubed plus b cubed. So you would do a plus b, and then your other factor would be a squared minus a times b plus b squared. So This is just a formula that we're using. So for example, if I was asking you to factor 8x cubed plus 27, this is a sum of two cubes because this is a perfect cube and this is a perfect cube. Now, if you're not sure what your perfect cubes are, you can make a list. So 1 to the third power would be 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125, and so on. So you can just, write those down somewhere in your notes if you want to so that you can recognize those. But if you have two things here and you can't take out a greatest common factor, then it probably is a sum of cubes. So I need to figure out what a and b are. Now supposedly this is a cubed, so I need to figure out what just a is. So in order to do that, I have to take the cube root. Now, if you don't know how to take the cube root of a number in your calculator, please come see me so I can show you how to do that, because you will need to know how. But if you have a scientific calculator, you press the 3, and then you press the second button, and then you press the x square root button like this. And the 3 replaces the x, so that's where we get the cube root from. And then you just type in the number. So if you don't know how to do that, I will show you. But if you take the cube root of 8, what number to the third power is 8? Well, it's 2. So I get a is equal to 2, and then the cube root of x cubed would be x, because x to the third power is x cubed. Then we need to figure out what b is. So b, if I take the cube root of 27, what number to the third power equals 27? Well, over here we can see it's 3. So now I know that a is equal to 2x and b is equal to 3. So if I plug them into this formula that I have, then my factors would be a plus b, so 2x plus 3. And then I have to do a squared. So a squared would mean I'm taking 2x times 2x, which would be 4x squared. So it's not 2x squared, because you have to take 2x times 2x. So that's a really common mistake. Then minus, and then I have to take a times b. So 2x times 3 would be 6x, and then b squared. So 3 squared would be 9. And that is the answer. Now, difference of cubes is very similar. The formula is just slightly different. So if you have a cubed minus b cubed, that would be a difference of cubes, and this would be the formula for that. You'll notice it's the same except for these two signs right here. So there's an acronym that we use to remember the formula if you can't remember. It's called SOAP. Same, opposite, always positive. So this symbol is the same as whatever this is. This symbol is the opposite of what this sign is. And this symbol is always positive. So on both formulas, if you look at them, this one's the same as whatever you have. This one's the opposite of whatever you have. And these are always positive, these last ones. So that's how we remember it. So let's try an example of difference of cubes. So we have 64x cubed minus 1. So I can take the cube root of these numbers to get a and b in my formula. So what would be the cube root of 64? Well, if you put that in your calculator, you'll get the answer. Or if you look at your list, what number to the third power equals 64? Well, it's 4. So this would be 4x, because the cube root of x cubed is x. And then the cube root of 1 is just 1, so b equals 1. So now I'm following my formula, and I have to do a minus b. So I have 4x minus 1. And then I have to do a squared. So remember, a squared would be 4x times 4x, which would be 16x squared. And then plus a times b, so 4x times 1 would be 4x. And then b squared would be 1 times 1, which would be 1. So this would be the answer. Now you can always check your answer by multiplying it out to see if you end up with 64x cubed minus 1 as your answer. So if I take 4x times 16x squared, I get 64x cubed. So that's one way to check those first numbers, because those are usually the ones that are incorrect. All right, and then I wanted to review factoring by grouping with you guys. So if you have a polynomial that has 4 terms, we have to factor by grouping. So first we have to group it into 2 pairs. So we would have x cubed minus 3x squared, and then minus 16x plus 48. So those would be our 2 groups. Just draw parentheses around both. Now notice I kept the minus with the 16. That's important. So then what you do is you take the greatest common factor from each pair. So what would be the greatest common factor of this group? I could take out an x, and the largest number I could take out would be x squared. So if I take out x squared, then I would have left over x minus 3. And then here, I need to factor something out, and I need to get x minus 3 is what's left over because I want those to be the same. So what I'm actually going to have to do, if the largest number I could take out would be 16, but I'm actually going to take out a negative 16 because then I would have left over x minus 3. And I need these to be the same. So sometimes you have to take out a negative to make that happen. So then my pairs would be x squared minus 16. And I can also take out an x minus 3 from both of those. Now I need to check to see if this is factored completely. So can I factor down x squared minus 16? I can, because this isn't a difference of squares. So if I were to take the square roots of both of these, then I would get x plus 4 and x minus 4, because that's the difference of squares. You have one that's positive, one that's negative, and then you still have the x minus 3. So this would be the answer that is factored completely. All right, last slide. Now, if you have something that's in a quadratic form, or this is considered quartic, remember we talked about to the 4th power is quartic, to factor completely, first you check to see if there's a greatest common factor. And actually there is not, but this is actually a different version of difference of squares, because I could take the square root of both of these numbers. So the square root of 16x to the 4th would be 4x squared, and the square root of 81 would be 9. So I'd have 4x squared plus 9, and then 4x squared minus 9. Now I need to check to see if this is factored completely. I can't do anything with this one, but this one is still a difference of squares, because I could take the square root of both of these. So I leave my 4x squared plus 9. And then the square root of 4x squared would be 2x. And the square root of 9 would be 3. So 2x plus 3 and 2x minus 3. And that would be the version that is factored completely, because I can't simplify anything else. All right, one more example. Okay, I need to check to see if I can take out the greatest common factor. And I can divide all of these numbers by 2. And I can also take out p squared from all of them. So I would have left over, if I have 8 and I take 2 away, I would have p to the 6th, plus 10 divided by 2 is 5. And if I have 5 p's and I take away 2, I would have p to the 3rd. And then 12 divided by 2 would be 6. And then there would be nothing else left. So I have this. Now, normally, to factor this trinomial, if this was squared, then I would find factors of 6 that add to be 5. So I could do 1 and 6. Nope, that wouldn't work. Let's see, I could do 2 and 3. Yes, that would work. So notice you have to keep checking sometimes. Now, when I write my factors, this is what's kind of confusing. You can do AC method with this if this confuses you. So you can leave the p to the 6th there, and you can replace the 5p to the 3rd with 2p to the 3rd plus 3p to the 3rd plus 6. So all I did was break this down. Okay, and then you can factor by grouping. So you can group these together, and we leave the 2p squared there. So the greatest common factor of this group would be p to the 3rd. And then if I take that out, I would have p to the 3rd plus 2. And then in this group, I could take out a 3. And then I would have p to the 3rd plus 2. So from that, I can take out p to the 3rd plus 2. And then I have left over p to the 3rd plus 3. And then I leave the 2p squared in front. So this would be my answer. Now, an easier way that you could do that is this is the same thing. We found 2 and 3 were our factors. So whatever your middle term is, that's what you're going to use to write your first answer. And we have to get p to the 6th, so you have to have p to the 3rd and p to the 3rd to multiply together. Otherwise, you won't get p to the 6th. So I could have just taken that once I found my factors, and I could have said, oh, it's 2 and 3. So that would have to be p to the 3rd plus 2 and p to the 3rd plus 3. So you can just do that too. So just pay attention to what your middle term is, and that's what these are going to be. All right, if you guys will go back and just take a look at the essential question and write your summary, then I will see you in class. Thank you.